Hello everyone, welcome to you all in this Math Magic channel, and today we are going to study about calculus derivatives. Okay, so calculus covers a vast course in mathematics of +2 level, and simply introducing calculus. So differential calculus is a theory which has its origin in the solution of two world problems, world problems. Okay, so one of drawing a tangent line to a curve and the other of calculating the velocity of non-uniform motion of a particle. In both the problems, the curves involved are continuous curves and the process used is the limiting process. So the objects of study in the differential calculus are continuous functions. These problems were solved in a certain sense by Isaac Newton, Gottfried Wilhelm Leibniz, and in the process differential calculus was discovered. Okay, so one important term in differential calculus or calculus is increment. Okay, so increment is just a small change in the variable. Okay, so a change in the value of the variable may increase or decrease. Okay, so change may include increase or decrease, but in either case we use the term increment to denote the change. Okay, so as for example, if the value of the variable changes from 2.0 to 2.0004 or 2.004 to 2.0, the change known as the increment is 0.0004. Okay, so so we have told about increment. So increment. Okay, so this is a small change. Okay, so I'm so sorry for this bad handwriting. Actually, this is a new software, so it's quite difficult for me to adapt here. Okay, so actually the increment is a small change in the given function. Okay, so it may be either increasing or decreasing. Okay, so generally we denote increment by delta. Okay, so if the increment is in x, so we denote it by delta x, and if the increment is in y, we denote it by delta y. Okay, so actually this is the system we include, and so sorry man, so sorry. Let y is equals fx. Y equals fx is a function. Then so let y equals fx. Then so if the y value, okay, so the value of y, if the value of y changes from delta y, okay, so the increment be y, then the value of f, okay, so then the value of f will also change. Simply we denote it by f of x plus delta x. Okay, so f of x plus delta x. Okay, so this is generated by this, And so there may be a little confusion regarding this, so don't be worried. I will be illustrating you all this. Okay, so first, if for example, if y equals to 3x plus 7, 3x plus 7. Okay, for example, y equals 3x plus 7, then let x changes from 3 to 3.01 3.01. Okay, so let the value changes from 3 to 3.01. so when x equals to 3, so when x equals 3, then the value of y will be 3 into 3 plus 7. Okay, right? So it will be equals to 16. Okay, so when x equals 3, it will be 16. So we are going to see the difference when there is an increment and when x equals to 3.01. so when x equals to 3.01, so when x equals 3.01, then the value of y will be how much? 3 into 3.0. oh sorry, so sorry man, so sorry. So this 3 into 3.01 plus 7. I think this value is going to give you 16.03. 0.03. okay, so this is going to give you 16.03. so the change in y, okay, so the change in y will be how much? So initially its value was how much? We calculated its value was 16 here. Okay, so but it later changed into 16.03. so the del y, change in y, del y will be 16.03 minus 16. okay, then the value will be 0.03. so okay, so this illustrated us that if there is small change in the given, okay, so if there is small change in the given function, then the whole function, or if there is small change in a given variable, then the whole function is going to be changed, or there is going to be an increment in the function. Okay, so this is I gave basic idea to you people. Okay, so there is a trend of calculating the derivative. As we know, derivative is small increment in something. Okay, so derivative is a small increment in something. What I'm going to do is, there is a fundamental theorem, or especially known as the first principle of a derivative, in which gives the other formulas like power rule, quotient rule of derivatives. Okay, so this actually, the let us suppose us that y equals to fx if x be in function. Okay, fx is in function. So actually the differentiation, not the increment in the function will be denoted by del y and del x. Okay, so del y and del x. So this is what going to happen in the given function if we add the increment. This we got from here. Okay, so this we have got from here. You people are clear, I think. So I'm using different thing. So actually what we are going to do is now subtracting the given function. Okay, so subtracting the given function, I'm so sorry. So this we are going to subtract of this function, and this del y and del y not, y and y is going to be cancelled out, and the remaining one will be del y equals to, okay, so this minus this. Okay, so actually I'm writing in the form where I can't, or where I'm avoiding the minus sign, or you people can do like in your way. The answer is going to be same. Okay, minus fx okay, so this is our function, and let us divide. Okay, oh no, this is lagging so much. Let us divide by del x. Okay, let us divide the given function by del x. Okay, so dividing the function, we get okay. So dividing by del x, we get del y over del x. Del x equals to okay, so f x plus del x minus fx over del x. Okay, so this is what we got from this. Okay, so actually the trend of differentiating any function is like this. Okay, so we differentiate the function on the basis of this formula only. So still it's not completed. Is this part. Okay, I'm so sorry for all those. You can pause the video and again you people can copy down. Okay, so now what we are going to do is we are going to limit, okay, limit del or limit x tends to 0, especially x tends to 0, del y over del x. Okay, so del y over del x, so it is going to give us equals to f x plus del x minus f x whole divided by del x. Okay, so oh sorry, I have forgotten to take a limit, so I am taking limit here, limit del x tends del x not x, I'm so sorry gentlemen, equals 0. So actually this formula, okay, so this and this are equals. Okay, so from here we can say that the the limiting value of the RHS exists. It is called the derivative or differential coefficient of y with respect to x. Okay, so and this we denote this by dy over dx. Okay, dy over dx. So actually this is going to provide us the differential coefficient of y with respect to x, or simply denoted by dy by dx. Thank you very much for watching up till the end. So this is only the episode number 1. Okay, or okay, episode number 1, and in the second episode we are going to discuss about the first principle. So actually this is also a backbone formula for the or to find the differential coefficient. Okay, but there is another principle named first principle, so you people can continue doing the or solving the problem by this formula also. So this is not a bad one. Okay, actually this is the perfect formula, I believe, because this give you the perfect value. Another one, that first principle, is a little bit longer. So okay, we'll discuss in next episode. Till then, thank you, goodbye, bye bye. Take math very easy. Take it easy, man, it's easy.